Let's solve problem 4.12 for Microelectronic Circuits 8th edition by Sedra and Smith. So in this circuit, we want to find a new value of R so that the peak current through the diode is limited to 50 milliamps. And this is an ideal diode, by the way. And then on this waveform here, we can see this is Vs, and this 12 volts here is just the battery. So we can see that the peak value of Vs is 24 volts. And we're going to use this value to do some simple KVL, right? If I want to calculate the resistance I need so that the current is limited to 50 milliamps, I can solve that just using some basic KVL. So we're just going to walk through this loop starting at Vs and sum up all of the voltages. So that would be Vs minus the voltage drop across this resistor, R times ID. And because this 12 volts, you can see the plus, we are crossing the plus, it'd be subtracted because this 12 volts is going against Vs. And we know that this should all sum up to 0 based on KVL. So now I just need to solve for R. So I can add R ID to the right side of the equation. So I have Vs minus 12 volts is equal to R and ID. And for this problem, I'm going to have Vs equal 24 volts because I'm interested in the peak current. So I'm interested in the peak voltage. And we're going to set ID is equal to 50 milliamps. So therefore, I can say R is equal to 24 volts minus 12 volts divided by 50 milliamps. And then let me get my calculator out. And so again, that was just dividing ID to the left side of the equation. And we get 240 ohms. So that's the problem.